me get through all the notes. So back in chapter 1, we talked about inductive reasoning. Does anyone remember what inductive reasoning was? It's like our very first day of notes. Michaela? Good. You're observing a pattern. So you observe a pattern, you see some type of pattern, you can continue it with a conjecture, and then we tested it. So instead of inductive reason, which was observing a pattern, today we're looking at deductive reasoning, which is more logical. Okay, so it is the process of reasoning logically from a given statement to a conclusion. And today we're going to use two different laws to help us reason deductively. Similar to postulates. All right, so the first one is the law of detachment. The law of detachment tells us that if we're given a conditional that is true, so remember a conditional is an if-then statement. I'll just put the notation, the P arrow Q, which is your conditional if-then. If you know that the conditional is true, and you know that the hypothesis, which would be the P part, is true, then you can conclude that the conclusion is true. So in order to use the law of detachment, you have to have a true conditional. I knew that was going to happen. This little box just keeps coming up. And a true hypothesis. Then you can come to a true conclusion. Now the law of detachment is used to make a conclusion about a specific thing, not just restating the conditional statement. And you'll see what I'm talking about in example 1 below. Okay, but it has to be a true conditional, a true if-then statement, a true hypothesis, and you can conclude the conclusion part. So for example 1, for the given statements, what can you conclude using the law of detachment? So you'll notice in the given it says M is the midpoint of a segment. So that would be my hypothesis. Right? Or my P. Then it divides the segment into two congruent segments. That's my conclusion. They also give me something else. They give me a specific example. They say M is the midpoint of CD. Okay, so if you're thinking about CD, M is the midpoint is what they're given to me. Okay? So M is the midpoint of a segment. They just happen to give you a specific segment now. So this would match up with the hypothesis, right? Just a little bit more precise and specific, talking about a certain segment. So we have a hypothesis and a conclusion, which is true. We're given a hypothesis, which we assume to be true. We can conclude then this part. But you have to be specific. So you're actually going to state what are the two congruent segments. You're going to state that CM, segment CM, is congruent to segment MD. So you're basically taking a given and applying it to a specific problem. Okay? I saw your hand up. But it has to be a given hypothesis. Like if I were to tell you CM is congruent to MD, you wouldn't be able to go backwards. It's always hypothesis to the conclusion. And that's because, remember, these are single arrow conditional statements, so you can't go backwards. You can only go forward. Next one, if you are a pitcher, so that would be our hypothesis, then you should not pitch a complete game 2 days in a row. That's our conclusion. They also give me that Matt pitched a complete game on Monday. So Matt is a pitcher, which matches my hypothesis. And they're telling me he pitched a complete game on Monday. We can conclude that he shouldn't pitch a complete game 2 days in a row. So if he did pitch on Monday, he should not pitch on Tuesday. So Matt should not pitch a complete game on Tuesday. So these were the easier ones because they're telling you that you can use the law of detachment. What gets a little bit harder is when they ask you, can you use the law of detachment? Is it possible to make a conclusion? Sometimes it won't be. So the next set of examples say, does each argument correctly use the law of detachment? Explain. So again, I would be labeling the hypothesis and conclusion part. That's why I did it in the top part, even though many of you didn't probably need to do that. So again, for the law of detachment to work, you need to have a true conditional, and you need to be given the hypothesis. Given the hypothesis. So, same statement we saw about M is the midpoint of a segment. That's our hypothesis, or our P, if you want to think of it. Arrow. This is my conclusion, which you can also think of as your Q if you're using the symbols. Now, looking at the second part of the given, which I'm going to add in, they should have segment and a congruent sign instead of an equal. But they give us that AM is congruent to MB. And they ask, can we conclude that M is the midpoint of AB? And a lot of you will say yes. The answer is no. Why? Using the law of detachment, we have hypothesis, conclusion. This part matches up with the conclusion. Two segments are congruent. It's giving me two segments that are congruent. You cannot go backwards to P. You can always only go forwards. Now, an example visually, for those of you wondering how would that work, well, we know M is the midpoint of a segment. It doesn't tell you that it's the midpoint of segment AB, though. It says it's just the midpoint of a segment. So technically, AM and MB could be like this and be congruent. Just because they're giving you this doesn't mean that it's necessarily the midpoint of that segment. Maybe it's the midpoint of another segment.
So if it said AB is a segment, then
if the given part had said
AB is a segment,
M is the midpoint of segment AB, then we would say yes, like in the example above. So our conclusion here is not possible. And the reason you'll always say it's not possible is that you don't know the hypothesis is true, or you weren't given the hypothesis part. That's the harder one to explain. The one below you'll probably understand a little bit better. If it is snowing, then the temperature is 32 degrees or below. Given it is 25 degrees, can we conclude that it's snowing? Think about it. Could it be cold and not snowing? Yes. So that one's a little bit more logical than the other one. But to show you with the law of detachment, here's our hypothesis. Here's my conclusion. P, arrow Q, or hypothesis, arrow conclusion. The given is that it's 25 degrees. That would match up with the Q part, the conclusion. Again, you have to be given the hypothesis because it's not a two-way arrow. So we, again, do not know this because we don't know the hypothesis is true. See if you guys can try 6 and 7 at the bottom. We are here until 43, but I am going to pass out the homework now just in case on the back we get rushed for time. So try 6 and 7.
So pretty much if you see that the conclusion is stated,
Given, then it's a no. Correct.
Okay.
Correct. You need the conditional and you need the hypothesis.
So
if
you
you're
can,
given
like,
the conditional and the conclusion, you can say not possible.
You would pretty much like just assume that it's true if you see the hypothesis first because.
Correct.
Okay.
Correct. All right, now on the back we're going to look at the law of syllogism, which is really hard and weird to say, but the law of syllogism is going to take two conditional statements and allow you to link them. So if you have one statement that is if P, then Q, and your second statement is if Q, then R, see how the link, they're the same? The conclusion of one is the hypothesis of the other. So you're able to link statement P directly to R, kind of taking out that Q. Now the only thing that makes this hard is that sometimes they don't put them in order. Like if P then Q, if Q then R, then P then R. Sometimes you'll see this. Q then R, and P then Q. And people will be like, oh, I can't do it. I don't see that common link because it says R and P. But you do have to look backwards. if you read it, the second part first, if P then Q, and Q then R, then P then R. So sometimes they won't put them in a nice reading order. You may have to reorder the sentences to see it, and I'll show you guys an example of that below. But you're looking for the conclusion of one is the hypothesis of the other, and then you can use this law to link the two together. So here we go. If Jordan pays attention in class, so that would be a hypothesis. Again, I label it with letters, but you don't have to. It'll make it easier though. Then, my arrow goes there. He will be able to do the homework. I'll label that Q. If Jordan is able to do the homework, well, that's the same thing as what they said up here. So I'm going to label that Q again, because it's the same statement. Then, arrow, he will do well on the test. Well, that's different, so I'm going to use a different variable R. But you could use A, B, and C, doesn't matter. Again, because the conclusion of this one is the hypothesis of this one, we can use the law of syllogism to link the P statement directly to the R statement. So we would say if Jordan pays attention in class, then he will do well on the test. Basically taking out the middleman, taking out that Q statement, so that you don't have to write two statements. If Jordan pays attention in class, then he will do well on the test. For the sake of time, we're going to skip the next one. It's the same thing. If anyone wants to watch it on the video, it'll be there now. Pause it. Now, the harder ones are, if possible, state a conclusion. Using the law of syllogism. If not possible, use the law to explain why. So this one says if Trinity goes to the playoffs, so I'm going to call that P, then, arrow, their opponent will be Mount Lebanon. Call that Q. It's different. Next sentence. If Trinity wins the next game, well, that's different than P and Q, so I have to call that R. Then they will go to the playoffs. Does the playoffs match up with any of my other labels? P. Trinity goes to the playoffs. They will go to the playoffs. That's P. So right now, if you look, the end of the first sentence is not the beginning of the next one. So you would think no. But if I were to take this sentence, the last sentence, and move it above it, I would have R arrow Q, R arrow P, then P arrow Q. Does everyone see how if I move the order of the sentences around, the ending would be the beginning? So you do want to say that. If Trinity wins the next game, then they will go, then their next opponent will be Mount Lebanon. Again, this is because they go to the playoffs, matches with they go to the playoffs. And you do have to start with this one, okay, because the arrows are not reversible. Some students like to rewrite the sentence above it, and then it reads better. If Trinity wins the next game, then they go to the playoffs. If they go to the playoffs, their opponent will be Mount Lebanon. Therefore, if they win the next game, their opponent will be Mount Lebanon. Okay, the next one, if a number ends in 6, then it is divisible by 2. So we'll have P arrow Q. If a number ends in 4, that's different, I'll call it R. Then it is divisible by 2. That's Q. So I have P arrow Q, R arrow Q, that doesn't work. R arrow Q, P arrow Q, not possible. Okay, you never have the ending of one matching the beginning of the other, so this is not possible. Very good. And then we'll do example 12 on Monday. No, you have the homework. You should be fine. I'm also going to pass out the study guide. You don't have to do this if you don't want to, but some of you might want to start studying. All right, the last example that we didn't get to in class, I will finish on the video for anyone watching, asks us to use the law of detachment and the law of syllogism to draw a conclusion. So we are using both of the laws to make sure that we can draw a conclusion. So we see if the bus for the away game leaves before 4 o'clock. That would be our hypothesis. Then an athlete isn't able to go home for dinner first. That would be our conclusion. Q. If an athlete isn't able to go home to eat dinner, Q, that matches up, can't eat dinner, then he will have to buy a snack in the cafeteria. That would be my R. So see how the conclusion of this statement is the hypothesis of this. So we can use the law of syllogism. Then they give us a specific part. Dalton's bus for the away game leaves at 3:45. So we're going to take Dalton's problem and apply it to the whole law of syllogism problem. So if the bus for an away game leaves before 4 o'clock, well, it leaves at 3:45. That's before 4. Okay? So we would be able to say then that Dalton isn't going to be able to get home to eat dinner, and he will have to buy a snack in the cafeteria. Dalton isn't able to go home to eat dinner, and Dalton will have to buy a snack in the cafeteria. And this only works for the law of detachment and the law of syllogism because this scenario about Dalton does match up with the original hypothesis. And since we were given that hypothesis piece, we can then follow the links all the way through. And the closure, same directions, use the law of detachment and the law of syllogism to draw a conclusion. They tell us that quadrilateral ABCD is a square. If a figure is a rhombus, that would be my P, then its diagonals are perpendicular, Q. If a figure is a square, well, that's not P, that's not Q, let's call it R. Then it is a rhombus, which is my P. So do we see again, this one's not in the correct order, but it's a rhombus is the conclusion. It's a rhombus is the hypothesis. So again, it might be easier if you were to actually read this sentence first and read that one second. So let's try it. If a figure is a square, then it is a rhombus. If a figure is a rhombus, then its diagonals are perpendicular. Okay? So we do see that the law of syllogism is going to work. We have R arrow P, and then P arrow Q, if I were to write them in the proper order. And you can see that the conclusion of one is the hypothesis of the other. Now we need to, with the law of detachment, look at this. We're given that quadrilateral ABCD is a square, which matches up with my very first hypothesis. This was the square. So it does work. So now what can we say about quadrilateral ABCD? If it's a square, it's also a rhombus. And if it's a rhombus, then its diagonals are perpendicular. So quadrilateral ABCD is a rhombus, and quadrilateral ABCD has perpendicular, that should say diagonals. The assignment is section 2.3, worksheet, and we do have a quiz on Tuesday.